So let's start with mathematical reasoning, okay? Mathematical reasoning via investigations of conjectures, okay? In mathematics, a conjecture, okay? You may have heard of this word before, okay? Have you heard of this word before, conjecture?
Yeah.
I think when you
Yes.
studied mathematical reasoning, you would have known this, huh? So a
Yes.
conjecture is a statement, it's a mathematical statement that appears to be true, okay, but has not been proven yet, okay. So a conjecture is a statement that has not been proven. It is like a guess or a prediction, okay. It is like saying, I believe that this is true, but I have no proof yet. So a conjecture is essentially a good guess or a prediction or an idea about a pattern. Okay, so we are going to see how we can go through the process of mathematical reasoning via investigations of conjecture. Okay, so example one, you are given this number pattern 2, 6, 11, 17. Okay, and you're asked to make a conjecture about the next number in the pattern. Okay, so your first step is to identify the pattern. What pattern do you see here? Okay, when we have patterns, normally the first thing that we look at patterns is the difference. Okay, 2 and 6 difference is 4. 6 and 11 difference is 5. 11 and 17 difference is 6. Correct? So can you see that the pattern is that the term is increasing first by 4, then by 5, and then by 6. Okay, that is our pattern, right? So what do you think is the conjecture for this? They're
Arithmetic.
asking you to make the conjecture about the next term, only the next term, okay? Okay, so what's our conjecture?
24.
Increase by
What is the
7.
conjecture? Conjecture is what's our guess? What is your guess about the next term?
24.
24.
24.
Correct, it's 24. But we need to explain a little bit. So maybe we will say that the next term will, this will increase 4, 5, 6. So what is the next? The next term will increase by
7.
7. Yes. So it it will be 17 plus 7 equals to 24. Okay, so we need to explain a little bit because they asked you to make a conjecture about the next term. They didn't ask you what is the next term. Okay, so you are predicting that the next term will increase by 7. So therefore it will be 17 plus 7, which is 24. Okay, so this is how we write a conjecture. Okay, okay, let's look at another example. Okay, example 2, okay? Adding even and odd numbers, okay? Investigate the type of number you get if you find the sum of an odd number and even number. Okay, express your answer in words as a conjecture and then use algebra to prove this conjecture. Okay, so first let's try some example. They ask you to investigate the type of number you get if you find the sum of an odd number and an even number. Okay, so let's try some examples first. Any odd number plus any even number. So supposing we have 23 plus 12. This is an odd number plus an even number. What do we get here? 35, right? So 35 is an odd
Oh,
number. So we have added odd and even, we get an odd. But just one example is not enough, okay? To actually express and conjecture, we have to go through many examples, okay? Let's take another example. Even number plus an odd number, we get 179, also odd. Okay. Another example, 11 plus 200, odd plus even, 211, odd. Okay. 45 plus 64 equals to 109, odd plus even, odd. Okay. 330 even plus 21 is 359. Okay. 49 plus 20 equals to 69. Okay, we have done 6 examples here. In all our 6 examples, we find that odd plus even or even plus odd is always an odd number. So what is the conjecture that we can make here? Anyone?
Addition of odd and even number equals to an odd number.
Okay, very good. Or in other words, we can write here the sum of any, because we're making a conjecture generally. Okay, we are generalizing the sum of any odd number and any even number is always odd. Okay, the sum of any odd number and any even number is always odd. Okay, so this is the conjecture that we have made. Okay, is there any example that doesn't fit this conjecture? Is there any example that doesn't fit this conjecture? Okay, never mind. So let's try to use algebra to prove this conjecture. If we can prove this conjecture, then we know that this conjecture will be true for any type of number, okay? We want to use algebra to prove. So we know that there are 2 types of number, odd number and even number, okay? So first, let's represent an even number as, how shall we represent it? Anyone?
X.
X, okay. But how do I know that that X is an even number? How can I be sure that that X is an even number? Even means if
Can
I want to
divide it by
make,
2.
yes, times by 2, okay? So I put it as 2X. So that means any number that times by 2 will be even. We know that, right? So then we know for sure that this is even. So how do I, if I say 2X is even, how do I represent the odd number? They are both different numbers, so I cannot use X, I use Y. But how do I show that this is odd? Anyone? Any ideas?
Just Y.
Just Y alone, huh?
Ah,
But that Y could be an even number, isn't it? How can I be very sure that it will be an odd number? If I put
2y
here
plus
2,
1.
yeah, what was that?
2y plus 1.
Okay, it's 2Y minus 1, okay? We use 2Y minus 1, huh? I suppose you can use plus 1 also. You can try that later, okay? 2Y minus 1, okay? Because we know that 2Y is a even number. So when you minus 1, it is an odd number already, okay? So now we want to find the sum of an odd number and an even number, okay? So the sum is 2x plus 2y minus 1, correct? And this is the same as 2x plus 2y minus 1. Or we can write this as 2x plus 2y, we put a bracket here, minus 1, correct? This is also equals to 2 into x plus y minus 1. Okay, from here we know that this number is even, correct? This part is even. Okay, therefore this whole number when you minus 1 is an odd number. So we have proven that an odd number plus an even number is always an odd number. It doesn't matter what, you can substitute any number that you want for x and y. Okay, you will still get an odd number. Okay, so with this, we have algebraically proven that our conjecture, the sum of any odd number and any even number is always odd. Okay? Okay so far?
Okay, madam.
Madam,
Yeah?
does conjecture is a formula?
A conjecture is a statement.
Oh,
A statement is usually a set of words, a statement that we make. Okay? Like we can say, what can we say? Like we say, this is just an example. Let's just say, okay, all girls are smarter than boys. That is a conjecture because I haven't proven it. So to prove the conjecture, there must be enough examples. Okay, I must be able to make sure that there's no situation where a boy is smarter, and then it is proven. If not, it will forever remain not proven. That's a conjecture. It's just a statement that you make an observation. You see so many things happening like the same time, and then you make an observation. Okay, but it is not proven, so you can't call it a theory or anything like that. It remains a conjecture until it's proven. Okay.
okay, madam.
Okay. Okay. Example 3, yeah? Multiplying a two-digit number by 11. Okay, the question is, consider the following examples of multiplying any two-digit number by 11. What pattern do you see? Eleven times 42 is 462. 11 times 71 is 781. 11 times 45 is 495. Is there a pattern that you see there?
Yes.
What's the
Yeah.
pattern?
4 plus 2, 6, and 6 put in between 4 and 2.
Yes, correct. Very good. So you notice that in the answer, the middle digit here is actually the sum of these two digits. This middle digit is the sum of these two digits. This middle digit is the sum of the two digits. Okay. So we notice in the answer that the middle digit. Okay. This is the pattern that you see. Yeah. The middle digit in the answer is the sum of the two digits, okay, in the original number. Okay, so this is the pattern that you see. So what conjecture can you make regarding any number that times 11? So your conjecture is the middle digit of the product. Okay, let me just write it down for you. Okay, the middle digit, product means multiplication. Of when you say product, we are referring to multiply. Okay. Okay, so your conjecture is the middle digit of the product's our answer, okay, is the sum of the two digits of the original number that is multiplied by 11. Okay, so this is your conjecture. From these three examples, we make this conjecture. Now we must check if there's any other example that will disprove our initial conjecture. Is there anything else that will disprove our conjecture? Okay, what about this example? Let's see. 11 times 67. What do we get?
One four seven. 137.
11 times 67 again?
737.
700.
737.
How about 11 times 56? 616, correct?
Yes.
How about 11 times 83? 930,
900.
correct? How about 11 times 75? 825. So all these examples, do they follow the conjecture? 6 plus 7 is 13. Is the middle number here 13? 5
No.
plus 6, 11. Middle number, not 11. 8 plus 3, 11. It's not 11 here. 7 plus 5, 12. So do these examples, they don't follow our conjecture, correct?
Yes.
Why? So now we need to change our conjecture. How can we change our conjecture?
Maybe if the addition below 10.
Yes, correct. So we can add to our conjecture, okay? We can put this right here. We can add on to our conjecture that the middle digit of the product is the sum of two digits of the original number that is multiplied by 11 only if the sum of the two digits is less than 10. Okay, so this only applies if the two digits is less than 10. If it's more than 10, then this conjecture is not true anymore. Okay, but for all digits less than 10, this conjecture is true. Okay, so that is how we Okay, that is how we have to check our conjecture. Okay, once we look at the examples, we form the conjecture. Then we must see if there are any other examples that does not fit the conjecture. If it doesn't fit, we have to reword our conjecture. Okay, now let's try to use algebra to prove our conjecture here. Okay, let's try to use algebra to prove our conjecture. Okay, so we start like this. Okay, any three-digit number can be written as any three-digit number. Say for example, if we have 582. So 582 is also equals to 500 plus 80 plus 2, correct? We have decomposed the letter, okay? Or we can write this as 100 times 5 plus 10 times 8 plus 2, correct? This is the place value. 100's place value, 10's place value, and the 1's place value, okay? So this is actually 1 times 2, the last one, okay? So any three-digit number we can write like this. Or generally we can say, we can write it as say z plus 10x plus y, correct? Any three-digit number, we can write it like this, okay? So a two-digit number can be written as can be written as 10x plus y, correct? So far, okay?
Okay.
The two-digit number can be written as 10x plus y, okay? So 11 times a two-digit number. 11 times a two-digit number can be written as 11 times 10x plus y, correct? Because this is our two-digit number. So 11 times a two-digit number can be written as 11 times 10x plus y. So this is 11 times, oh sorry, this is, we open the bracket. So 11 times 10x will be 110x plus 11y, correct?
Yes.
So this also equals to 100x plus 10x plus 10y plus y. Okay, so this also equals to 100x plus 10 into x plus y plus y. Okay, so that is why when we have any two digits, we plus the two digits for the middle number. Okay, so that's why when 11 times by a two-digit number xy, okay, you get 100x plus 10x plus y plus y. So the middle digit is always x plus y. Okay, so this is proven. Can you understand?
Can we use some example, madam?
Um, okay, let us now we did 11 times 32, right? So 32 is xy, correct? So 11 times 32 will be 100. Let's try, 103 plus x plus y plus y. This is 300 plus 50 plus 2. 352, is that correct?
Yes.
Okay. Okay. So this one, if you haven't seen the examples like this, it's quite difficult for you to do. But once you have done a few examples like this, then you generally get the idea. You know where to start from, usually. Okay. So this is what we mean by mathematical reasoning via conjectures. Okay. Okay, so now we're going on to our next topic. Okay, we're going on to our next topic. Our next topic is multiple intelligences. Okay, how to teach using multiple intelligences. We want to teach mathematics using multiple intelligences. Okay, so this multiple intelligences was first proposed or introduced by Howard Gardner. Okay. Okay. Howard Gardner is a psychologist and a professor at Harvard University's Graduate School of Education. Okay. Based on his study of many people, he developed this theory of multiple intelligences. This is a very old theory. Okay. It's been around for a very long time, but it's still true until today. Okay. Gardner defines intelligence as the ability to solve problems or to create products. Okay. This is his famous definition. Okay. Multiple intelligence, or intelligence is not your ability to score 100 marks in the exam, but it is the ability to solve problems or to create products which are valued in one or more cultural settings. If you know how to solve problems, if you're good at solving any problem, then you're considered intelligent. And he also said that intelligence is not just like scoring well in your exam, or it is like, he said different people have different types of intelligences. Okay, and he classified these intelligences into 8 different types of intelligence. I'm sure you know that now there is more than 8. Okay, but we are focusing on these 8 only. Okay, so according to Gardner, there are 8 types of intelligences. That is logical mathematical intelligence, linguistic intelligence, spatial intelligence, musical intelligence, bodily kinesthetic intelligence, interpersonal intelligence, intrapersonal intelligence, and naturalistic intelligence. That means all of us can have different kinds of intelligence. It doesn't mean that you only have one. We can have more than one, but we are usually very strong in one particular intelligence, okay? So if you are in a class, if you are a classroom teacher and you're in a class of 40 students, or what he's saying is that the students in your class, they all can have different kinds of intelligences. So that means as a teacher, you must teach according to all the different kinds of intelligences. You don't just focus on one. Right now, we all focus on verbal linguistic. If you can read, write, and talk, you do very well in your exams, okay? Okay, let's look at all this intelligence one by one, okay? First intelligence, logical, mathematical intelligence. Okay, students are logic or math smarts when they think in numbers, patterns, and algorithms. Algorithms is when you solve a problem step by step. If you're always that kind of person, very systematic, you always do this first, and then after that, this, then this, like that, then you have logical mathematical intelligence, okay? People with logical mathematical intelligence like to reason deductively. Deductively means general to specific. They think clearly, logically, analytically. They solve logic problems easily. They love to solve logic problems. This intelligence is most often associated with scientific and mathematical thinking. Okay, famous people with logical mathematical intelligence like this Albert Einstein and John Dewey. Okay, second intelligence, verbal linguistic. Verbal means speaking. Linguistic is to do with language. Involves having a mastery of language. They're very good with their language. This intelligence includes the ability to effectively manipulate language, to express oneself rhetorically and poetically. Word smart students have good vocabulary, spell easily, write clearly, and think in words. Okay, students with verbal intelligence, verbal linguistic intelligence, they always do well in examinations. Sometimes we have some very good students. They understand the concepts, they can build things, but when it comes to exam, they don't do so well. You will expect them to get A+, but they end up getting only an A because they're a bit low in verbal linguistic. They don't like they can't write very well. They cannot express themselves very well in written form. Okay, all our exams are verbal linguistic form. Okay, so all those students who have very high verbal linguistic intelligence, they all do well in the exams. Those students who don't have very high verbal linguistic, but they're very high in other intelligences, they don't do so well in standard exams. Okay. Okay, visual spatial intelligence. This is art or space smart students. They think in pictures and images. They have a good eye for detail and color. When you talk to them, they already see everything in pictures. Okay, they learn through visuals. They like to draw, paint, and create. They are good with space relations, and they see solution. They see the solution instead of thinking about this. When they have a problem, they already see how to solve it in their mind. Okay, these are visual spatial intelligence students. Okay, and then we have musical intelligence. These are music smart students. They have a good sense of rhythm and melody. They like to sing, hum, chant, and rap. When they're studying, you see they'll be tapping their fingers and shaking their legs. They are very musically inclined. They enjoy listening to music and creating music. They read and write music, and they learn through music and lyrics. They like to sing songs. Okay. Then we have the bodily kinesthetic intelligence. These are body smart students. They have the ability to coordinate one's own bodily movements. They have the ability to use their body skillfully to solve problems, to create products and present ideas. They have an ability, obviously displayed for athletic pursuits, dancing, acting artistically on building and construction. But more importantly, students who are bodily kinesthetic intelligent, they like to learn through hands-on activities. So for this kind of students, we need to give them a lot of manipulatives, and they have concrete manipulatives. They can manipulate it, use it, turn it, that kind of things, move it. They like to learn that way. Okay. And then we have the interpersonal. Interpersonal means these are people who like to work in groups. They like to socialize, okay? The ability to work effectively with others. They like to interact. They learn by interacting with others. They understand and respect others. They display empathy and understanding. Notice their modifications and goals. These are students who like to learn in groups, okay? They enjoy being in groups. Okay. And then we have the intrapersonal. Intrapersonal students are self-smart. They have the ability to self-analysis and do reflection. They are usually quiet students, okay? They quietly assess one's accomplishments. They review one's behavior and innermost feelings. They are always reflecting on their own achievements, okay? They like to keep diaries. They like to write journals, okay? They're always thinking about thinking. Okay, these are students with intrapersonal intelligence. And finally, we have students with naturalistic intelligence. Students who love nature, nature smart, ability to discriminate different flora and fauna, plants and animals, have keen observational skills. Yeah, they can observe very well. Okay, they understand natural phenomena. They're good at sorting and classifying. They use this ability productively, for examples in hunting, farming, or biological sciences. Okay, these are students who like to go out and learn in nature. Okay, so these are the 8 different multiple intelligences suggested by Howard Gardner. Okay, can we be more than one? Can we have more than one type of intelligence? Yes, most of us have more than one type of intelligence. Okay. 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 Um, okay. For logical, mathematical intelligence, as a teacher, the kinds of activities that you can give the student, okay, they include problem solving, okay, things like measuring, logic games, experimenting, critical thinking, using algorithms, okay? These are the kinds of activities that you can give the student. For linguistic intelligence, what kind of activities can we give them? Stories, okay? We can give them stories, ask them to write reports, okay? Making presentations, listening and reading activities. All these cater for linguistic intelligence students, okay? Spatial intelligence students, we need to use like photographs and pictures in the classroom. We can ask them to paint, draw, sketch, make mind maps, color things, okay? This will cater for spatial intelligence students, okay? For musical intelligence students, okay, we have a lesson that includes singing, okay, music, patterns of playing instruments in the class, okay. For bodily kinesthetic intelligence, we can have games, hands-on experiments. We can use a lot of concrete manipulatives in the class. We can have role-playing or drama, okay, for bodily kinesthetic intelligence. For interpersonal intelligence, cooperative learning is a very good activity in the classroom where we put students in groups, ask them to do group activity. Okay, so group activity or study groups or clubs will be very good for interpersonal intelligence. For intrapersonal intelligence, they like to study on their own. So we can have individual study, individual projects, or ask them to do journal writing, write reflective journals, and so on, okay? And finally, for natural intelligences, what we can do is we can take them out of the classroom, okay, to observe mathematics concepts in nature, okay? Any questions so far?
Madam,
Yes.
do we have to include all of the intelligence in one class?
Do you think it's possible?
Not possible.
You think it's not possible?
But I'm just asking what is the best we
Okay.
can do?
Okay, before that, let me give you one example. Okay, supposing I want to teach proper fractions in class. Huh?
Okay.
Say I'm a teacher and I want to teach proper fractions and I have a class of 40 students, all different kinds of intelligence. Okay, there are many things that I can do. Maybe when I come into the class, I can start with set induction. Huh? Set induction, I can use song a song on proper fractions. Okay, I give them the song and the class can sing together. For example, like I don't know if you've heard this song, cut a pizza into half and call it half and so on. Okay, there are a lot of fraction songs available. So you come to class, for set induction, you put the lyrics on the board, ask the whole class to sing. Okay, so what multiple intelligence are we catering for here?
Musical intelligence.
Yes, so we have done musical already. It's first step, step one. So we finish with musical. After I've done that, because I'm teaching proper fractions for the first time, maybe in step one, I would say I give them flashcards. I show them flashcards like with fractions written on it. And I ask all the students to read aloud the fractions and also to write down in words. In words. I ask all the students to do this. What intelligence am I catering for?
Verbal and gambar tu? See.
Visual also, huh?
Visual.
Visual spatial,
Special.
yes, correct. Visual spatial. See, I already have two multiple intelligence in this activity. I show them many cards, one by one. Say I show them one by one. Ask the whole class to read. They'll say 1/4. That is verbal. And then when they ask to write down, it is linguistic, verbal linguistic. And when they see the cards, it could be visual, spatial, or it still could be verbal linguistic here, okay? More of verbal linguistic, yeah? Okay, and then step two, I want them to build some models of these fractions using Cuisinart rods. Say they will use 1 unit and 2 units here. These are Cuisinart rods. This is to show 1/2 or to show 1/4. They will use this to show 1/4. These are Cuisinart rods. Cuisinart rods are 3D rods, manipulative, concrete manipulatives. So what multiple intelligence is involved here? Anyone? If they use concrete items, then it is bodily kinesthetic. Okay? Bodily kinesthetic. Kinesthetic means movement. It could be your whole body is moving everywhere or just your hands moving, okay? So it's bodily kinesthetic already. I ask them to do this, okay? So maybe after this, I put them in groups. Step 3, I put them into groups and I ask them to play a game, a board game, okay? A board game on fractions. They have to like match the fractions. They have to match the fractions, okay? Maybe before this, okay, this is step 4, okay? Maybe before this step 3, I ask them to draw the fractions given, okay? Draw the fractions given. So maybe you give each student one card like this. They have to draw the fractions like this. They can use any diagrams and they can draw fractions like this, okay? So this is step 3. So here when they ask them to draw, this is already visual spatial already, okay? In step 4, I put them in groups, ask them to play a game where they have to match fractions. They are playing in groups. Because they are playing in groups, what multiple intelligence is involved here?
Interpersonal.
Yes, interpersonal. Here they already interpersonal already. Okay. Okay. And then maybe I want to, of course, when they're dealing, because this is mathematics, and when they write mathematics is abstract. So naturally in the whole lesson, you will have mathematical, logical, okay? Because for math subject, we cannot run away with that. And then finally, maybe closure, I ask them to write a reflection. Write a reflection on what you learned today. Okay, a lot of teachers have journals. Ask the students to keep journal. Every day they have to write a reflection on what they learned today. So when they do this, this is self or individual work. Therefore, this is
Intra.
personal. So in this lesson, I've used all the multiple intelligence except for the naturalistic. If before the closure, I take them outside the classroom and I ask them to show me where you see natural fractions, 1/2. Show me buildings or flora or fauna where you can see 1/2, then it will be naturalistic intelligence. Okay, so in one class, although you don't realize it, but we actually can cover all the intelligences. Okay, but to answer your question just now, you don't have to do that. You don't have to do all the intelligences. Okay, but when you plan your lesson, thinking about all this intelligence, you find that you end up with a very good lesson plan. Yeah, the lesson plan at the end will satisfy all the students, and your lesson also flows very well with so many different kinds of engaging and challenging activities. So they teach you all this so that when next time when you go to class and you want to plan a lesson, there's so many ways for you to plan a lesson. You can use the connection model and you can plan your lesson, or you can use all these multiple intelligences and plan your lesson. You can look at your lesson and say, okay, have I catered? What are the intelligences have I catered? Then if you see your lesson, everything is verbal linguistic, then you know that it's not a very good lesson plan. You have to change. Okay, because as a teacher, you want all the students in the class to learn, not just the verbal linguistic students. Okay, any questions?